Welcome to Unit 4, Lesson 6, Squares and Square Roots. Let's compare equations with squares and square roots. Let's take a look at our exponent laws and keep these in mind for the entirety of this unit. Okay, so when we look at these equations, when you solve an equation, let's say our variable is x. The coefficient, the number in front, must be positive 1. The exponent, the number to the top right, must be positive 1. Now, all of these have an x squared. We know that squares and square roots are opposite. To get rid of a square root, you have to square something. To get rid of a square, you would take the square root of it. So for the first one, we take the square root of both sides. X equals plus and minus 2. Plus and minus the square root of 4, which is plus and minus 2. Okay. Next one. Take the square root of both sides. X equals plus and minus the square root of 2. 2 is not a perfect square. Learn your perfect squares up to 25. That will help you a lot. It comes up in a lot of math and science problems. Take the square root of both sides. The square root of 0 is 0. The square root of negative 1 is no real solutions. Later on in this unit, we're going to introduce you to a new number system where we'll be able to solve this one. But for right now, there are no real solutions. So we're talking about the real number system, which includes rational and irrational numbers. Rational numbers have several categories. You got your integers, you got your whole numbers, and you got your natural or your counting numbers. Counting numbers start at 1, going whole amounts to positive infinity. Whole numbers add 0. Integers are whole numbers with signs in front of them. And rational numbers are any numbers that can be a fraction, any decimal that can turn into a fraction, or any fraction that can turn into a decimal. Well, all fractions can turn into decimals. Irrational numbers are decimals that cannot be turned into a fraction because they do not repeat and they do not end. So that's the difference between rational and irrational numbers. And all of these number groups make up the real number system. And there's another number system we're going to learn in a couple of lessons, around lesson 10. Here's one of these hypothetical math questions. So let's talk about it. For all intents and purposes, that's going to be the best answer. When you take the square root in problems, most of the times you're looking for the principal square root, which is the positive square root. Now, if you get a multiple choice question that asks you, or an extended response question that asks you for all or many of the roots, then the other ones come into play. But for most cases and multiple choice questions, let's deal with the positive square root. So yes, all of these are valid, but the one highlighted is the best answer if you're looking for one answer. Okay, complete the table. X is in the top, the square root of x is in the bottom. So we just had to take the square root. Square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. Square root of 4 is 16. Then 5. Square root of 16 is 4, not 16. Why did I write 4? Then 5. And finally, 6. Okay, now they want us to plot the square root of x. The square root of x makes a funny curve. So at 4 is 2. At 1 is 1. 0, 0. 1, 2, 3, 4. This is 4 is 16. 5 is right there. It's 25. 6 is 36. So when you take the square root of x, you get a curve that looks like that. And this is why when you take the square root, we only take the square roots of positive numbers for now. Is the rule y equals the square root of x a function? Yes. How do we know? For any function to be a function, you have to pass the vertical rule test, the vertical line test. If you drop a vertical line on a function, it can only cross the function once. So when I drop this vertical line, it only hits the function in one place. I can drop an infinite amount of vertical lines and I will only hit the function one time. So it's a function. Explain how you could use the graph to find any solutions to the equation x equals, the square root of x equals 5. There's one solution because the square root must be equal to a positive number for now. And we just square both sides of the equation, or we find it on the graph. So x equals 25. Use the graph to approximate the value of the square root of 5. Since the square root of 4 equals 2, the square root of 5 is really close to 2. About 2.1 or 2.2. Approximate any solutions to x squared equals 20. We take the square root. X is equal to the square root of 20. The closest square root is 16 and 25. 20 is 4 away from 16 and 5 away from 25. So it's going to be closer to 4. So you could say like 4.2 or 4.3. Just approximating. You can always do it in a calculator and get an exact, a better representation or a closer representation of the number, the actual root.